Have you ever tried to truly feel how big a planet can be? Not calculate it, not memorize the number, but actually feel it. Because numbers break down when size becomes extreme. Kilometers stop helping. Miles lose meaning. At a certain point, scale becomes emotional rather than mathematical. In this calm, slow-moving space documentary, we won't rush through facts. We won't overwhelm you with statistics. Instead, we'll gently stretch your sense of scale, one world at a time. We'll begin at home, on Earth. Then we'll move outward to Jupiter, a planet so large it already feels impossible. And then, far beyond Jupiter, to planets so massive they sit at the very edge of what we even call a planet at all. Some of these worlds blur into stars. Some challenge the definitions of astronomy itself. And some may be the largest planets that can exist in the universe. So take a slow breath, let your shoulders relax, and allow your imagination to expand, quietly, gently, into the deepest reaches of space. Earth feels enormous when you're standing on it. Mountains stretch beyond the horizon. Oceans seem endless. The sky feels infinite. But this feeling comes from proximity, not true size. Earth is just over 12,000 kilometers wide, a number that sounds large until we compare it. Now imagine placing Earth next to Jupiter. Jupiter is so large that Earth would barely register as more than a dot beside it. You could line up 11 Earths across Jupiter's diameter. You could fit more than 1,300 Earths inside its volume. And yet, even that description fails to capture what Jupiter really is. Jupiter isn't a solid surface. It has no ground, no place to stand. It's a massive sphere of gas and liquid hydrogen, collapsing inward under its own gravity. Its storms are older than human civilization. Its gravity shapes the orbits of asteroids, comets, and even planets. For most people, Jupiter is already beyond imagination. And that's where our intuition fails. Because Jupiter is only the beginning. Beyond our solar system, planets come in forms we never expected. Some orbit their stars so closely that their atmospheres boil and expand. Some are newborn giants, still glowing with leftover heat. Some are so large that astronomers debated whether they should even be called planets. Planets like WASP, 17b, HAT, P, 67b, and Trace. For B have radii far greater than Jupiter's. Their atmospheres stretch tens of thousands of kilometers into space. If Jupiter is a basketball, some of these worlds are beach balls. Thin, swollen, and enormous. Yet many of them weigh less than Jupiter. They are giants, but fragile ones. They exist at the edge of stability, inflated by heat, light, and tidal forces. These discoveries forced astronomers to rethink everything they knew about planets. Because size, it turns out, is complicated. Why bigger doesn't always mean heavier. When we talk about enormous planets, we are really talking about three different ideas. Radius tells us how wide a planet is, how far it stretches from side to side. Mass tells us how much material the planet contains, how strong its gravity is. Density tells us how tightly that material is packed. On Earth, these values are intuitive. But for giant planets, they break apart. A planet can be enormous in radius, yet extremely light. Another can be compact, small, and unimaginably massive. Once a planet reaches roughly Jupiter's mass, adding more material doesn't make it bigger. Instead, gravity compresses it. The planet collapses inward, becoming denser rather than wider. This is why the largest planets by size are not the most massive ones, and why planets have a natural size limit imposed by physics itself. Behind a certain point, objects stop behaving like planets. When an object becomes about 13 times the mass of Jupiter, something strange happens. It can begin fusing deuterium, a heavy form of hydrogen. This process doesn't make it a star, but it makes it something else, a brown dwarf. Brown dwarfs glow faintly from internal heat. They are born like stars, but never grow large enough to shine fully. The boundary between giant planets and brown dwarfs is not clean. Some objects form in disks like planets, but grow too massive. Others form like stars, but end up planet-sized. Nature doesn't care about our categories. And that's why some of the largest planets may not truly be planets at all. They are cosmic in-betweeners. Finding massive planets around distant stars is an act of precision. Astronomers watch stars for tiny movements, wobbles smaller than the width of a human hair seen from kilometers away. When a massive planet orbits a star, its gravity pulls the star slightly back and forth. This motion shifts the star's light, revealing the planet's presence. Other times, astronomers watch for a gentle dimming. When a planet passes in front of its star, it blocks a fraction of the light. 4 giant planets. That fraction is just large enough to notice. From these faint signals, entire worlds are uncovered. Worlds hundreds or thousands of light years away. Worlds larger than anything orbiting our sun. Invisible until mathematics makes them real. Some giant planets don't behave the way we expect. Their gravity is so strong that atmospheres collapse inward. Their internal pressure reshapes their structure. Their magnetic fields dwarf entire solar systems. At extreme sizes, these worlds blur into stellar physics. They generate heat internally. They glow faintly in infrared light. They resist clear classification. They may orbit like planets, but internally, they act like failed stars. This is where planetary science meets stellar science, and where the universe reminds us that categories are human inventions. Imagine existing within the clouds of a truly gigantic planet. There is no sunrise from a horizon, only gradual shifts in color as storms rotate overhead. A day might last only a few hours, the planet spinning rapidly under immense angular momentum, or it might stretch endlessly, slowed by tidal forces. A year could be just days long, with the planet hugging its star, or centuries long, drifting through deep space. Time behaves differently here, not because clocks change, but because scale changes everything. As planets grow, everything intensifies. Gravity deepens. Atmospheres thicken. Storms become planetary in scale. Cloud layers stack endlessly, one above another. Winds reach thousands of kilometers per hour. Lightning discharges release unimaginable energy. On some giants, a single storm system could swallow Earth whole. These are not gentle worlds. They are dynamic, violent, and awe-inspiring structures, living systems of gas, motion, and gravity. As Earth shrinks beside Jupiter, and Jupiter shrinks beside giants beyond our solar system, scale stops being something you calculate. It becomes something you feel. A quiet reminder that the universe builds without concern for comfort or familiarity, and that our home, small, solid, and calm, is rare in ways size can't measure. Every giant planet begins quietly, not as a world, but as dust. Inside vast disks of gas and debris surrounding young stars, microscopic grains collide. They stick, they clump, they grow. Over millions of years, these fragments become solid cores, many times the mass of Earth. At a certain point, gravity takes over. Gas rushes inward. Hydrogen and helium pour down like cosmic rain. The planet grows rapidly, swelling in size and mass. For giants like Jupiter, this process stops naturally. But around some stars, conditions allow growth to continue. More gas, more mass, more gravity. And so, the largest planets in the universe are born, not suddenly, but patiently. Jupiter formed early, before the sun's disk vanished. But some exoplanets formed in even richer environments. Their stars were larger. Their disks were thicker. Their building materials more abundant. These planets fed longer. And the longer a planet feeds, the larger it becomes, until physics steps in and says enough. This is why the universe creates giants, but not infinitely large ones. Growth always meets resistance. Some of the largest planets are not massive because of what's inside them, but because of what's happening outside. When a giant planet orbits extremely close to its star, intense radiation heats its atmosphere. The gas expands. The planet swells. Its outer layers puff outward into space. These planets are enormous in size, but fragile in structure. Their atmospheres leak. Their edges blur. Their shapes are not fixed. They are planets slowly being stripped away by light. Some giant planets glow faintly even without intense starlight. This glow comes from leftover heat from formation, slow gravitational contraction, internal pressure releasing energy. These worlds shine in infrared light. They are warm, but not alive like stars. They exist in a quiet thermal balance, cooling over billions of years. Some of them may one day fade into darkness entirely. Giant planets shape everything around them. Their gravity redirects asteroids. Their presence controls planet formation. Their movement can either protect inner worlds or destroy them. Some systems are dominated by giants close to their stars. Others scatter giants into distant orbits. In some cases, giant planets migrate inward, sweeping smaller planets away. In others, they stabilize entire systems. Without giants, many solar systems would never look the way they do, including ours. The giant planets themselves are hostile, crushing gravity, no solid surface, extreme radiation. But their moons are another story. Around Jupiter-sized planets, entire families of moons can exist. Some may have oceans. Some may have heat. Some may be sheltered beneath thick ice. In distant systems, moons of giant planets could be among the most habitable places in the universe. Life may not live on giants, but it may thrive in their shadow. There are planets so distant, so cold, and so faint that we may never detect them. Free-floating giants drifting between stars. Massive planets orbiting far from faint suns. Ancient worlds with no light left to reflect. The universe is filled with giants we will never name. Worlds that exist quietly, without ever being observed. When we encounter extreme size, something happens to the mind. Scale dissolves. Perspective shifts. Importance changes. The largest planets remind us that Earth is not the standard. They show us that nature builds freely, without concern for comfort, balance, or familiarity. They stretch imagination beyond habit, and in doing so, they calm it. Picture Earth again. Now, Jupiter. Now something twice Jupiter's size. Now something heavier, denser, glowing faintly. At each step, numbers stop helping. What remains is sensation, a quiet awareness of immensity. The largest planets are not important because they are big. They are important because they show us what is possible. They reveal the extremes of formation, the limits of physics, the flexibility of nature. They remind us that our planet, small, solid, and gentle, is rare not because it is large, but because it is calm. So let the giants exist. Let them swirl, glow, collapse, and drift. And let Earth remain small beneath the stars. There is a limit to how large a planet can be. Not a limit imposed by technology, not by observation, but by the laws of physics themselves. As a planet grows more massive, gravity tightens its grip. Atoms are squeezed closer together. Pressure rises beyond anything we can recreate on Earth. Eventually, adding more mass no longer increases size. Instead, the planet becomes smaller. This is the strange truth of giant planets. The largest possible planets by radius appear to max out at around 1.5 to 2 times Jupiter's size. Beyond that, worlds collapse inward. This ceiling tells us something important. The universe allows giants, but not infinite ones. At roughly 13 times Jupiter's mass, something fundamental changes. Deep inside the object, temperatures rise high enough to fuse deuterium. This process releases energy. The object begins to glow faintly, not brightly like a star, but noticeably. This is the realm of brown dwarfs. They are not planets in the traditional sense. They are not stars either. They occupy a quiet middle ground. Some of the largest objects we call planets may already live here, misclassified not by mistake, but by necessity. Because nature doesn't care what we name things. For decades, giant planets were invisible. We inferred their presence. We measured their effects, but we did not see them. That is changing. With telescopes like James Webb, astronomers can now directly image massive exoplanets. They appear as glowing embers beside their stars. Warm, young, enormous. For the first time, we're not just detecting giants, we are observing them. Their atmospheres, their heat signatures, their chemical fingerprints. The era of indirect discovery is slowly giving way to direct understanding. Future observatories will go even further. They will detect colder giants, older giants, worlds drifting far from their stars. They may reveal entire populations of massive planets we didn't know existed. Some may orbit faint red stars. Others may roam freely through interstellar space. The largest planets may not be rare at all. They may simply be quiet. Not all planets orbit stars. Some are born in crowded systems, then thrown out by gravitational chaos. These free-floating giants wander the galaxy alone. No sonrisa, no seasons, only slow cooling over billions of years. They are invisible to most instruments, but they may be common, perhaps even more numerous than stars. Entire worlds drifting silently through darkness. There's something soothing about extreme scale. When confronted with something vastly larger than ourselves, everyday concerns lose weight. Deadlines soften, noise fades, perspective widens. Giant planets remind us that existence is not centered on urgency. The universe moves slowly. It builds patiently. It lasts unimaginably long. In that context, stillness makes sense. One final time, imagine the scale. Earth, a small, solid sphere. Jupiter, a giant of gas and gravity. A planet twice Jupiter's size. Its atmosphere glowing, its edges blurred. A brown dwarf, dense, hot, and heavy. At each step, familiarity dissolves. What remains is not fear, but awe. The largest planets teach us something subtle. That importance is not tied to size. That dominance is not tied to meaning. That small things can matter deeply. Earth is small, but it is calm, stable, alive, and that may be the rarest condition of all. So now, let the giants remain distant. Let them swirl in silence. Let their storms rage unseen. Let their gravity bend space far away from us. Here on Earth, the ground is firm. The air is gentle. The night sky is quiet. As you rest, remember this. The universe allows worlds so large they erase intuition. Yet it also allows one small planet where you can breathe. That balance is enough. Slow your thoughts. Let the scale fade. And rest inside the vastness. If this journey through the largest planets helped you slow down, take a moment to let it settle. If you'd like more quiet explorations like this, through galaxies, black holes, and worlds beyond imagination, you can gently support the channel by subscribing. There's no rush, no notifications you need to chase. Just calm stories about the universe, waiting whenever you're ready. If this video brought you peace, you're welcome to leave a like or a comment. It helps these long, quiet documentaries reach others who need the same calm tonight.